I'm happy to announce Renaud Lifshitz and his talk, Android Geolocation Using the GSM Network. And the subtitle is, Where was Waldroid? I hope we're going to learn what this is, what this is going to be. So I think we're good to start. Renaud.
Thanks. Hi, everybody. Welcome to my talk. First of all, let me introduce myself. I'm Renaud Lifshitz, coming from Paris, France. I'm a computer security engineer. I do mainly penetration testing, security trainings, and security research in my company. And my main interests are security of protocols. That means authentication, cryptography, information leakage, zero-knowledge protocols, and so on. And another interest is number theory, probability testing, factorization, and so on. So don't worry, there won't be any math theorem or complex proofs in my talk. Don't bother with that. So first of all, why Android and not iPhone or BlackBerry, for instance? Why not? In just 2 years, in fact, Android has made an impressive market share. Okay, so for now, nearly 300,000 phones are activated each day, according to Google, Andy Rubin, who is the director for the Android part of Google activity. And now Android sales overtake iPhone since summer. So Android is now a big part of the phone nowadays. And the last point is because hacking with Android is very cool. You have a true, real Linux kernel, so you can hack many, many things. So these are the market shares for Android phones, iPhones, BlackBerries. So you see now Android is becoming the second largest market share in the US. Well, no, let's talk about the geolocation, because this is far more interesting than the little introduction. So to geolocate a phone, you have different ways to do that. Okay, you can use the integrated GPS you have on most phones. Okay, the GPS is very accurate. You can have a 3 or 4 meter precision with the GPS. But the problem is that you need a GPS in your phone. This is not the case for all phones nowadays. Okay, and the user must switch it on. Okay, it's not enabled by default because of the battery consumption, right? Another problem with the GPS is if that doesn't work inside the buildings because you don't have the satellite view, nor underground, for example, in the subways. Okay, so you can't locate yourself in the subways or in the buildings. So that's a problem. Another way to geolocate yourself is to use Wi-Fi. Okay, Wi-Fi, on the contrary, works inside buildings. So you can locate yourself at work or at home. No problem with that. But you need Wi-Fi on your phone. You need to switch it on. And it's far less accurate than GPS because the coverage for a Wi-Fi access point is about 300 meters. Okay, so it's not very accurate. Okay, and you need, of course, access points in order to triangulate your position. Okay, if you don't have any access point near your building, you won't be able to locate yourself, right? So these are the two classical ways to locate yourself. The last way, and the most interesting way, is the GSM location, right? So here you don't need a Wi-Fi or GPS. So it will work with all GSM phones, okay? And it can be done from the network side. You don't have necessarily to install an application on your phone to have a smartphone, okay? With a very old phone, you are able to geolocate yourself because this is made from the network side, okay, and not from the user side. The disadvantages are you have a very low accuracy, okay. GSM cells can extend to nearly, I think, 30 kilometers. So in cities, in big cities, there is no problem because there are lots of BTS, that is to say, GSM access points. So in the cities, you have a quite good accuracy, which can be a 100 meter. But when you are far from the city, for example, in the seaside, you won't be able to geolocate precisely, okay? And of course, you need GSM coverage, but it's easier to have GSM coverage than to have Wi-Fi coverage. So how does it work? How can you locate yourself using GSM? You have to know that every GSM cell, every BTS, which means base transceiver station, is identified by actually 4 numbers, okay? First number is MCC. MCC stands for Mobile Country Code. This is the country code you are in, okay? So these are normalized codes, which are not the prefix you dial on your phone. These are other codes, okay? For instance, in Germany, it's 262, right? Second number is MNC. MNC stands for Mobile Network Code, and this is a code for the operator, for the network operator, right? For T-Mobile Deutschland, for instance, the code is 1, okay? Because this is the first network operator in Germany. Third number is a code about the area you are in, okay? So cells are grouped into areas. And usually big cities are divided in 5, 6, 7 large areas, which can be more for some cities. And in an area, you have different cells. So the last number is the cell ID, which is the code for the ID in the area, right? So with these 4 numbers, you are able to know in which cell precisely you are. Right. So this is not new. So there have been several attempts to build databases of GSM cells because it's not easy to have a clear mapping between those 4 codes and, for example, GPS position. Okay, the cells are attributed by network operators, but they keep the database for themselves. So the cell positions are not public, right? So there have been attempts to build database of all cells in many countries, in many operator networks, right? So you have, for example, location.api.com, which have nearly 11 million cells in the database in more than 200 countries, right? So you can find all those databases in Wikipedia, right? So this is a first try to geolocate yourself using only cell IDs. But why not use something more efficient, like Google indexing power? Okay, instead of indexing yourself cells, okay, which means a lot of effort, okay, a lot of human task, human power. Why not use something completely automatic, which is regularly updated, like the Google indexing power, right? So how does it work? It works using Google cars. I'm pretty sure you have already heard about Google cars. These are the cars that build the Google Street View, okay? That takes pictures of all streets, okay? The Google cars not only take pictures of streets, house, and all the surroundings, but also index all Wi-Fi access points and all GSM BTS, okay? So they have a pretty complete database of GSM cells, okay? They keep it secret, but they have it, right? And they have not only the Google cars, they have all Android users also. Because your Android phone is constantly updating this database when you use, for example, Google Maps, okay? So all Android users are updating this very large Google database. So this is continuously updated and quite good quality. But is there a Google API somewhere? Okay. Yes, but it's quite confidential. Quite confidential. There is a Google API. In order to be sure there is a Google API, try to run a Google Map with the GPS and the Wi-Fi disabled. Okay? So your phone will only be able to geolocate using GSM, right? So I have tried this, and I have seen there is some kind of API the phone uses to be able to geolocate, right? Another entry point to the API is when you install a Google Gears plugin. It's not so much known, but it's a plugin for Firefox and Chrome, which allows, for example, cache browsing or local search. I mean, when you type restaurant in Google, it finds the pizzeria just in front of your building. So Google is able to know where you are, okay? Just by sniffing the query from the Google Gears, you are able to figure that there is an API, right? But this API, of course, when you are running a local search, doesn't use GSM because you don't have a GSM receiver in your desktop computer. So it's only using Wi-Fi access point, right? So first of all, let's talk about Android Google Maps internals, right? So I have compiled a TCP dump for my Android phone, which is a Nexus one. So you need to cross-compile TCP dump for ARM architecture, because of course the phone doesn't run an Intel processor, right? And I noticed there were some exchanges in binary. So this is a proprietary binary protocol, right? But it uses HTTP and HTTP post to this URL here, right? GLM mmap. Some people have figured it out also. So you can look at this excellent blog, this excellent blog page, which is called the Poor Man GPS. And some people managed to successfully reverse engineer this binary protocol. So in fact, you just have to pack the 4 different codes we talked about. So the MCC, MNC, LAC, and CID. You have just to pack them in the proper format and send them in binary to the google.com server, right? And you have an answer also in binary. But it's quite buggy. Okay, I mean, when you basically do twice the query, you don't have the same answer sometimes. So it's quite bizarre. Have a look now at Google Gears, sniffing Firefox plugin. Okay, and now it's a lot easier because it's simple JSON, right? So it's plain text. You don't have to reverse engineer many things. The only problem is that it only use Wi-Fi and basically no GSM, right? And you have a quite confidential page which talk about Google Gears API on the google.com website. Officially, it's deprecated in the page, okay? But it works very well. It's not buggy at all. It works very well. It's easy to use, easy to understand, and it's regularly updated, okay? Have a look at the query and the response. So you see it's a simple post HTTP query. And you just have to format a correct JSON request with the 4 codes we talked about. That is to say, the MCC here. So 208 stands for France, right? The mobile network code. This is the first network operator in France, which is Orange. The location area code, which is the code for the area here, and the cell ID. So this is the query. Have a look at the answer now. And in the answer, you have interesting details. Not only you have the latitude and longitude, which is pretty nice. You have a full human readable address, including street number, street name, zip code, city, region, and country. So you have a complete reverse geolocation using only the cell IDs, right? And you have even the accuracy, which I think is the cell coverage. It couldn't be anything else. So it should be the cell coverage, in fact. So here you see the accuracy is not so good, 500 meters. And we can go further by mapping the entire GSM network in a given area, right? Using sniffing, because every single BTS broadcasts its cell ID, its location area code. So if you sniff the GSM network, and there have been a talk about GSM sniffing, if you sniff the GSM network, you are able to collect all LAC and CIDs from your area, right? You can do that using SDR, which is a software-defined radio. So here you have one well-known SDR, which is the USRP1 from Etus Research. Okay. quite expensive, but it's a very good toy. If you want something cheaper, you can buy a simple Nokia. Okay, this is a very old Nokia version. You can find it for nearly 15 euros on eBay. Okay, so buy it. It's a very good hacking toy. And you will be able to sniff the broadcast from the BTS. So in order to achieve that, I used the AirProp project, which is a project for GSM sniffing. Okay? So first of all, you have to scan the frequency to find all the different BTS with GNU Radio. Okay? When you have identified the good frequencies, you have to demodulate the signal with AirProbe. And when you have the demodulated signal, you have to decode it with Wireshark. Right? So 3 simple steps. And here is the result from the demodulated capture. So T-Shark is basically Wireshark in console mode. Okay, so this is a clear version of Wireshark. I take the decoded capture as an XML file here, and I just apply a filter in order to only keep the packets with cell IDs, right? And here in the capture, you see you have 4 different BTS broadcasts with MCC, MNC, LAC, and CID. And I was able to map nearly 1 square kilometer of Paris from my bed without moving from my home, just by using the USRP and listening to broadcast. Okay, so this was the introduction about the geolocation with BTS. Now let's see how we can attack an Android phone. So Android uses a specific logging facility, which is quite unknown, and it's unfortunately enabled by default. Okay, Android has 3 or 4 different logs. It depends on the Android phone you have. Okay, these logs are not plain text file like log in Unix or in Linux. Okay, these logs are in fact circular memory buffers, right? So it means they have a very limited size, and they will be truncated after this given size, and they will start over and again, right? These logs files are actually handled by character device files, like character device drivers in Linux, right? So character device drivers are not easy to handle. So there is a built-in tool in every single Android phone, which will help us, fortunately, to manage these logs and to read these logs. The tool is the logcat tool. Have a look at the logs. So the logs are character device in /dev/log, okay? But these are no text file, okay? These are character device, so you cannot directly read those files. So you see here 4 logs: the system log, the radio log, the main log, and the events log, right? And here you see the C which stands for character device, right? You can notice something strange, okay, about the permissions. Carefully look at the permission of the log files, right? You will see other as the right permission on those logs, okay? This will be important in the next steps. Now with the logcat utility, you can have a look at the log size, okay, using logcat -b. This is to select a given log, okay, and -g is to query the character device for its size, okay. So you see most logs have 64 kilobytes data, right? Have a look now at the contents of the log files, okay? So if we try to read them as standard log files, we will see that in fact they are in binary, okay? So you have text in them, but you have binary fields, you see, on the very first line, for example. So what does it stand for? In fact, some data are binary encoded, like, for example, the timestamp for the events in the log files. So these are for the timestamps or the PID of the program that issues the lines, right? Now have a look at the radio log, which is probably the most interesting log on Android phones. So issuing a logcat with the radio log in the verbose mode, so in order to show the time -v. And -s is to set a filter on the log in order to have only the log files from the RILG daemon, which is the daemon that handles the GSM chip on Android phone, right? So what can we find here? We can find lines with the operator keyword, and at the end of the line you have the MCC and MNC of the operator, right here. And in other lines with the keyword registration states, you have the LAC, which is the location area code. So in what area you are, and the cell ID, which are eggs encoded, right? So here you see you have two different cells because the cell ID is different. There is a small difference in the cell ID, you see. And you have the corresponding time in the logs. So that means you have a complete history of your trip during the day in your Android phone, right? So the attack scenario will be to collect this history of visited GSM cells on the victim side, because you need access to the victim phone in order to do that. But you don't need any prior access. I mean, if you have access at a time, you will be able to read the history, so you will be able to see where was the victim, 1 hour, 2 hours, 3 hours before, okay? So this is an history, so you don't need a prior access. Then you need to send this history to yourself, or send them to the attacker, and you have to resolve them into latitude and longitude. Of course, in order to know, to draw on a map where was the victim, because cell IDs are not of any help to know where's the victim. So how can we do that? In fact, there are two principal ways to do that. You can do that locally. Here, this will mean you have physical access to the victim phone, right? So this can be your friend phone on the table. This can be your kid phone, your spouse phone, for instance. So if you have physical access, no problem, okay? We'll see that in a few slides. Or you can do that remotely, but remote here doesn't mean we will use a remote vulnerability. In fact, we will better use a local vulnerability and a bit of social engineering, or not. It depends. So how does physical attack works? You just have to connect the victim's phones to the attacker computer via USB. So if you have access to a phone, just for a few seconds, you take it and you plug the USB cable and you dump the logcat, the radio logcat. Okay? This takes only 3 or 4 seconds. This is very, very quick. Okay? And it even works if the victim's phone is locked, thanks to the USB debugging function you have on Android. Right? So this was the physical attack. Now let's talk about the most interesting attack range, the remote attack. This will allow you to remotely spy the victim using a malware. So you need a local access to the phone. So the best way to do that is to install a malware on the phone, which will abuse either the trust of the user, okay, or the Android security model, because there are flaws in this security model. So this will require a bit of social engineering or some flaws. How does security works with Android? Okay, Android, you probably have downloaded an application on the Android market. When you download an application, the market asks you if you want to install this application, and will list all the permissions needed for this application. So theoretically, an application cannot use a permission which is not declared in its manifest file. Okay, so this is a fine-grained permission model, which is far more secure than the iPhone application. Okay, and for this, in order to ensure that the application doesn't use any other permission, you have a Java sandbox, because Android applications are in Java, or a subset of Java which is called Dalvik, in fact. So permissions are listed in the Android.permission package on Android. So you have a bunch of permission in Android security model. And what can a user fear if he don't want to be located? If you don't want to be located, you will carefully look at permissions for location, like access find location, which use the GPS, for example, or access coarse location, which use Wi-Fi or GSM network. So if you don't want to be located, you will carefully look at those 4 permissions, those 2 permissions, sorry. And probably you won't authorize application which use the internet access, okay? Because with the internet access, the application will be able to report your location, okay? So you will carefully block the application which use both permission. This is a big danger. So first attack is using both permissions. Okay, most users, in fact, won't care. Okay, most users don't look at permissions and will install a game which use the location permission and the internet permission, even if the game isn't related to internet or to location at all. Okay, I mean, most users don't care. Okay, why? Because internet permission is quite used in Android application because it's needed for a free ad-sponsored application. For the ad in the game, you need internet permission, right? And geolocation permission is needed for location-aware application. Like when you do a local search in Google for a restaurant, for example, you need the location permission. Okay? So most users won't care. So this is the first naive attack. Second attack is much more sophisticated and it's based on radio logs. Okay? Instead of using Android geolocation API, you only read radio logs, so you don't need the location permission, any location permission. You just need the read logs permission. Okay? So you are able to read and parse the radio log and to collect the different LAC and CIDs from the logs. Second part of the attack is to write those results in the system log, okay, which is another log. And you don't need any permission to write to system logs because this is used for debugging. Okay, so you can write anything in the system logs. You don't have to declare any permission to write the system log. Third step is to voluntarily crash the application, for example, using a null pointer exception or that kind of things. Okay, and you don't need any permission to raise an exception. Okay. Fourth step is the crash reporting step. Okay. When an application crash, you have a feedback client on your Android phone, which sends the developer the system logs at the time the application crash. So you don't need any internet access to remotely collect the cell IDs. You use the integrated Google feedback client, right? So this is the principle for reporting bugs, okay? You have an angry user which finds a bug, who report the bug to the developer, and the developer fixes the app, and the user is happy. So this can be abused, okay? Here is a voluntary crash in the application. So for example, a null pointer exception. So the application crash, and you have the choice to force close the application, okay, or to report the crash. And when you click on report the crash, the system logs will be sent to Google, and Google privacy condition explains that they share the system logs with the developer in order to fix the program, and the developer in its developer console will be able to see all user reports by exception types. Okay, so here you have out-of-memory errors or null pointer exception and all the reports. So this is second attack. Third attack is even stronger because you don't need any permission. You just use the Android NDK. Android NDK is the native development kit for Android. And NDK allows developer to completely bypass permissions model because you are able to call native code from your Android application. This is to say you are able to execute C or C++ code directly in your Java application. And of course, this C or C++ code does not run in the sandbox. So you are able to read any file on the phone, to write to any file on the phone, to execute any code, and to have network access without any permission needed. And force attack is the last minute ID. So if you have any feedback about this attack, I will be very happy. Okay. Force attack is a man-in-the-middle attack during application download over Wi-Fi. Okay. Since Android 2.1, you have a new system for downloading applications from the market. Okay. You have a download manager, an integrated download manager, and this integrated download manager works in plain text HTTP to download the application. Not only to download the application, but to see the application name, application description, and application permissions just before downloading the application. So by doing active man in the middle, you are able to change application description, you are able to change application permission, which will be shown on the phone, and you are even able to replace the application content by another content, which can be a malware, for instance. So when the user downloads a game, for instance, he will in fact download another program, which can be a malware, without noticing it. Because the Android download manager only checks for a digital signature, which means the applications come from the Android market, but you can replace an application by another. And the user won't notice anything because the application is signed. So this is the query used to download an application in the Android market. So you notice it's simple HTTP in plain text. So no problem to do active man in the middle. So that was the biggest part. But we can do more than geolocate users. Okay? There are much more interesting information in the different logs, because here we have seen what was in the radio logs, but you have actually other information you can find in radio logs or in other logs. Okay? You have all phone calls, okay? Numbers and duration of phone calls. And you have even all SMS messages. All contents of SMS are in logs. Okay? They are just encoded in a well-known format, which is the PDU format. So you just have to decode the SMS, but the actual content of the SMS is in the logs. Okay? So you have the sender, the recipients, the dates, the time, and the content of the SMS. So you are able not only to geolocate the user, but to collect all phone calls and all SMS messages from the targeted phone. So you are able to figure out now where did phone calls take place, where the SMS were received or sent, and you are even able to recover deleted SMS or deleted call history directly from the logs. So what's the history length? How much time you can recover by reading the log? This is actually a good question, a difficult question, because it will depend on log filling. I mean, if the user has moved quite quickly for the last hours, or has sent several text messages, for example, or has issued several phone calls, the log will fill very quickly. So you will be able to recover only a few hours of activity. But if the user hasn't traveled a lot, hasn't found a lot, you will be able to recover the activity for a whole day. Okay? But remember, with the logcat tool, you can change the log size, and you can, in a malware, you can multiply the log size by 10 or by 100 in order to be able to gather user activity for a month or for 2 months. So now you have complete geolocation, calls, and SMS history tracking with nearly or no permission needed. How to protect yourself now? Don't buy an iPhone. I mean, Android security model is quite strong because for each application you have a different user ID and group ID, which you don't have on iPhone. Okay, iPhone applications share the same rights. You don't have so much fine-grained permission model in iPhone. Okay. And you don't have hidden or forbidden API on Android. I mean, Apple can forbid API usage. This is not the case on Android. So the security model is much more stronger in Android phone. So don't buy an iPhone. Okay. A few recommendations. First of all, carefully look at applications that use the NDK. Okay? Does anybody in the room care about that? It's nearly impossible to see because you have to download the APK archive file and extract it in order to see if there are .so files in it. Okay? You can't do that from the phone before downloading the application. So this is actually a hard part, right? Be careful also not to install any application requiring read logs permission, because we have seen that this allows the developer to recover your entire location, calls, SMS activity. So don't install any application requiring read logs permission. Don't submit bug reports, or at least disable the submission for system logs, because you have the choice. By default, system logs are sent during bug reports, okay, using the Google Feedback client. But carefully have a look at the Google Feedback client and uncheck the box which sends the system logs. So you will be safe. You can reduce the logcat buffer size for your privacy. Okay, so this is a bit tricky and a bit buggy, but you can try logcat -r and logcat -n to play with the log size and the buffer numbers, right? You can clear your logcat regularly, so this is very easy, and you don't need any permission to do that. So even with a non-rooted phone, you can clear your logcat, for example, in a cron task or using a dedicated application. So this can be done with logcat -c, or you can disable radio logs, but it's a bit tricky and you probably need root access to do that and to patch the startup scripts of your phone. So this is a bit hard. Have a look at a small demo now. So this was very hard to do an actual scenario here because I didn't travel a lot this day. I stay here. So this is not very interesting. I will show you just how to actually. Okay, the virtual machine crashed, so this, this is not a good case. But what does the tool? I will release a Python tool after the event that actually dumps the logcat when you connect your phone via USB, dump the logcat, collects the different cell IDs, and resolve the cell IDs in latitude and longitude, and builds a Google map with all the different positions in the day, okay, with their associated dates and time. So you see here, this was last August. I went back to home after work. So my work is nearly here. You see, I've left the work at 20 past 6, and I arrive at home nearly 14 minutes after, but I stay at home up to 11 p.m. Okay, so you have here nearly 5 hours of history in the phone. But I travel quite a lot because I cross nearly all Paris in order to go back home. So I will release the Python tool in order to do that, to automatically do that from any Android phone. This will be on Google Code, right? After the event. So that's all, folks. Hope you enjoyed the talk. Many thanks for attending. If you have any questions, feel free to ask them.
All right. Thanks very much for the great talk. Time for questions. Can we get your mic and you use this? Right.
Hi, I was wondering if you have had experience running your Nexus 1 or any Android phone with disabling the logging features of the radio or turning the logcat to the radio device file to 0 and seeing if there's any problems or issues with the Android system while you do that.
Well, sorry, can you repeat a little bit more slowly?
If you reduce the log size of the radio device file to 0, I was wondering if you have tried this on your Nexus 1 or any Android phone and noticed any problems.
Actually, I never tried to reduce to 0 the log file, but it won't raise any issue. I mean, the radio log are never read, so this is not a problem if you reduce the log file at the minimum size. I don't know what is the minimum size actually, but this won't be an issue, and this is recommended for privacy.
All right. More questions? One question, 2 questions from the interwebs.
Yes. So the chat room wanted to know since which version of Android included error log reporting.
Which version of Android are vulnerable? All versions since 1.6 at least, but probably 1.5.
Okay, and then the other question was that question was from Nuremberg. The other question was from down in the Hack Center, and somebody said that they just checked on 2 Android phones and there was only MCC and MNC in the log. Could it be that the information recording the cell ID is only acquired and logged if Use Wireless Networks is activated in the My Location settings?
Perhaps they have not enabled the geolocation by network in their settings. Because you have an option to use Google Maps even if you don't have any GPS or Wi-Fi. So there is an option which is called, I think, use network location or something like that. Perhaps it's not enabled.
All right, more questions from the audience in the back?
Hi. I tried the lock cut on this X10 Sony Ericsson phone and it doesn't have read access, so probably it's not working for all the phones. He said every phone is possible. With root access, of course, I can log all things, but normal users doesn't have read access on all the logs he mentioned.
What did you actually try to do?
I used the terminal application,
Yeah.
which is quite similar to the debug mode, and typed logcat and says permission denied. No read access for other users.
Yeah.
RW.
Yeah, that's normal because the terminal application hasn't the read log permission, so you cannot read the logs from the terminal application.
Okay,
you
so
need
in
to read the
debug
log.
mode you have more rights.
Sorry?
In debug mode, I would have more rights. You mean?
I didn't catch, sorry.
Okay.
Would he have the permission in debug mode?
In debug, no. It depends on the application. The terminal application doesn't have the read logs permission, so you cannot read the log unless you are root. Okay, when you use a rooted phone, you will be able to read the logs with the terminal application. Yeah. Or you can read the log from an application which have the read logs permission, or from NDK, from a native application which use NDK, okay. Right? Other questions?
Yeah, you said that NDK does not use the rights management. So if I download any app from the market, can it be that it has more rights than actually listed on the rights list because it uses NDK internals?
NDK-enabled applications will have more rights, which doesn't mean they will have all rights, because they will be limited to Linux permissions then.
Okay, but it means that not every right needs to be listed in the rights list when it uses NDK.
Sorry?
So, well, if a normal Dalvik app, lists every right that is requested, for example, GPS location, right to read GPS location. But if you do it over NDK as an app developer, this right doesn't show up in the list. Is it correct?
Yeah, if you use any native API, this will not be listed in permission used by the application.
Okay, and do any market apps use native API?
Sorry?
Do any apps listed in the market use this API, this native API?
Of course, yes. You have several video player which for performance reason use NDK for video decompression, for instance.
Okay,
so if you have a look at, for example, vPlayer, which is a really nice Android video player, it will use NDK for video decompression to read DivX files or AV files.
Okay, there's another question.
Hi, so is there any way to tell when I install an app from the market if it uses the NDK compiled code? Is there any way to see it from a user standpoint?
Unfortunately, you cannot see it from the market, so you have to download the APK archive and extract it in order to see if there are any .so files inside. But there are no way on the phone, in the market application, to see that. You will have to use a file manager to extract the APK and see if there are .so files.
Okay, one last question.
Hi. It's actually not true that using the NDK bypasses all permission checks, because permission checks are not done at the Dalvik layer. For example, the terminal app is native code, and that guy didn't get the automatic power to read logs. It's permission checks happen at the IPC boundary, not at the Dalvik boundary. Dalvik is not intended to Dalvik is not intended to be any security boundary. It happens elsewhere at the IPC boundary. Whenever like you cross the process boundary by making a call across binder, for example. So if you can bypass any or all permission checks merely by using native code, that would be a huge bug and you should report it to Google. But I don't think it will turn out to be true.
Okay, good remark, but using NDK doesn't allow you to do anything. You are limited to Linux permission. I mean, if your application is not in the right group, for example, to read the log file, you won't be able to read the log file from the native application. Okay? But you will be able, for example, to open a socket, because opening a socket doesn't need any permission at the system level.
Actually, there's a special blob in the Linux kernel that blocks your access to the socket API unless you have the permission, the internet permission.
I haven't seen this, and I was able to do network request without any special rights.
Have you written a test app to do that?
Yeah.
And it works?
Yeah.
That's a bug.
All right. So it seems we end on having discovered an Android bug, possibly. All right, let's thank the speaker again for this great talk. And
just a word. If somebody managed to attack an application download using active man in the middle, please mail me. It will be very interesting. But I'm pretty sure you can do that.
okay, unfortunately, we have to stop at this point.